My name is Avi Kavale, and I'm the co-founder of Shippable. What we are is basically a containerized application delivery platform. And what I'm going to talk about is how we internally use containers as well as Amazon infrastructure to manage our service. And it's kind of like Catch-22. We also use the same platform as a product that we sell to our customers. For now, just think of it as this is Shippable using just Shippable internally to build Shippable. So the point I want to talk about is what is exactly DevOps, right? I mean, there's a lot of definitions, a lot of chaos about what this means, and nobody seems to really define what this is, right? So what I really care about is not so much about what it is. What I care about is why do we need to care about this? And I don't care what the definition is. Let's focus on why we need this and then take it from there. So to start with, how many people know this person? Nobody? So I'm not surprised because this person lived about 100 years ago, and his name is Rube Goldberg. And he was a cartoonist, and he used to write interesting things. And what he came up with was this thing called the Rube Goldberg's machine. And what this was basically cartoons that used to get printed, and it was all these things. A lot of movies have used this. Mr. Peavy has this whole thing where the toaster comes up and he wakes up. All the stuff has happened, right? So that's basically, I mean, the reason why I say this is, I mean, this is kind of the thesis around which Shippable was actually created. So what this is you have a very complicated solution to do something super, super simple. And that's the irony of it, and that's what got it very viral back in the 1900s. And this sometimes can be poetic and entertaining. And before I jump into my thing, I want to show you a video. It's a couple of minutes long, but I think it's fun to kind of watch it. This is one of my favorite videos growing up when I was at school. I don't know how many people have seen this. So the budget for that one was about $10 million. It took 3 months to build it. And about 50 people were actually working on it. And this was, I mean, this is not even the creation of the concept. This is just once the concept was in place, just to get it going. So the execution plan was kind of a very common theme, which was they broke down that whole thing into 10 segments. They kind of parallelly executed on this, and then eventually they brought it all together in a big, giant warehouse and tried to film it in one shot. So sounds awfully similar to how software is built. You kind of build microservices, you kind of have 2 pizza teams, which all execute in parallel, and hopefully you kind of bring this all together in one shot and do a production deployment. I mean, that's kind of what people typically do. So the final filming, what you saw was the 606th take. And they had to reset the whole thing back all over again every single time it didn't work. And it took over 4 days. And all it was, the challenge was getting all these pieces to work together. And that was where they spent a ton of time. Everything worked within that piece, but when you got it all together, it was where the challenge was. Sounds awfully similar to what software is. And you kind of do production deploys, you roll back, you do a whole bunch of things, and then eventually you deploy and it works, and you start having post-launch bugs. And so this is basically the fundamental thing of how we build software and why DevOps kind of starts becoming super important. But the key is the Honda Cogs crew, that was a Honda Cogs video, just had to do it only once. They needed this to work on the 606th take, whatever it is. They thought it was going to be the first take, but it took them 606. But they never had a 607th. And that was the key difference, right? But in software, the apps have to be continuously evolved. And it's not about just getting that work one time. You have to get it to work again and again and again because you're going to change it. The moment you deploy, it's already the prior version. You have the vNext going right now, and that's going to come down the line. And so the point is, in software, you have to innovate or you will perish. And I think everybody understands this. And I just want to kind of drive in the point a little bit more. NASDAQ is at 5,000 today, around 5,000 plus. 15 years ago, it was at 5,000 plus. 8 of the top 20 companies, NASDAQ is a tech index, by the way, 8 of the top 20 companies that existed on NASDAQ do not even exist anymore. I'm not even talking about they're not in top 20. They don't exist as companies. And that's how fast you can pretty much perish if you don't innovate. So to kind of define that, and you say, hey, this is all about innovation, the question I ask is, what is the first thing people ask when there's a software outage? Any chance, any guesses? So I think usually it's what changed. And this is kind of ironical, right? I mean, you know that you have to innovate to actually survive, and then the first thing you do when something goes wrong is, what the hell changed? The problem is not this. The problem is the second question. Any guesses on the second question? It's who changed it. So the thing is, this is where people start getting irritated, because now suddenly everybody is trying to do CYAs on top of what they want to try to do, because they don't want to be this person whose name comes up because something broke in production. And both of these questions are really, really, really bad for your business. And this is where I think you have to really think about, one, kind of create slowing down, which is checklists and stuff that people have. Other one is you start pointing at who caused the problem. And now all the microservices don't work anymore. And the thing is, it pushes you towards extinction. And it slows you down over a period of time. And at Microsoft, when I was there for like around 11 years, to deploy an app, we used to have 250 checklist things that we had to do to make one single change. And sometimes it was just a production bug that we had to fix. And so it has changed a lot today, but this was like 5 years ago is how we were talking about. So in order to survive, what you really need to do is to embrace DevOps. And what it guarantees, or at least promises you, is you get speedy innovation with quality and repeatability. I mean, this is the promise of DevOps, and that's why we care about DevOps. The thing is, we are done. QED, everything is done. But why are we still here talking about this? And why the hell are we talking about containers if all of this was already done? And the reason is this. The problem is about how DevOps is being done. It's not about the promise. It's not about the goals. It's about how it actually is being achieved. And the reason why I say that is over 53% of all dev resources or engineering resources are doing things that has nothing to do with the change that you're actually making. And that's why it is so important to kind of say, why are we still talking about it, is because it hasn't solved the problem that we really wanted. We have lost productivity at this point of time. And this is my experience at Microsoft, and it's also validated by a whole bunch of independent research that people have done. You can kind of search. Electric Cloud did one. Reddit has a whole big thing going on. And this is kind of from that. Now, people start questioning, that's not really true. But actually, if you think about it, we broke it down and started looking at why this is 53%. And the answer is 10% was authoring automation code. But the irony is 14% was waiting for that automation code to actually run and trying to wait for the results. And then in spite of it, you had 19% of the time debugging environmental inconsistencies. How many times people have heard it works on my machine? It doesn't work there. It doesn't work here. So you're having all these chaos that's going on. And this is all with DevOps. And people think we are spending a ton of time in meetings, but it's really not true. I mean, it's a very small fraction of what you're doing on a daily basis. So if I want to kind of explain why this is true, let's take a simple 3-tier app. Developer, development team, UI, DB, and API, nothing fancy. So the thing is, I want to deploy this into a dev environment. So I go to Amazon and say, I want to buy some machines. So you want to do automation. So what you do is you ask your DevOps kind of role person to say, give me some infrastructure automation code. And they write this. And then you realize I have to now deploy it into these VMs. So you write application deployment code on top of it. And you got your dev environment going. And you're pretty much happy. The question is, now I want to push this to test. The real question is whether the same infrastructure code runs in my test environment. And it usually is not true. And it's because the test is a different topology, different machines, different ports, different sizes, all kinds of stuff that they're doing in test. So what ends up happening is you write yet another set of infrastructure deployment code for test. And you probably share a lot, or you have a whole bunch of if-then-elses between these statements to kind of say, if I'm in test, if I'm in dev, doing that kind of stuff. Now, your infrastructure is different, so your deployment code is different. So now you wrote another thing. And of course, you want to deploy this into production. Now it's completely different. So you have a whole bunch of sets again. So this is a simple 3-tier app. And what we ended up with is 18 RGMs that are all sitting here to actually get your application to go through. One for infrastructure, one for application. If you kind of put this into a picture, it looks something like this. So this is a simple 3-tier app with 3 environments. The moment you start increasing any of these axes, it starts going exponentially crazy. And this is where a lot of chaos happens. Which environment is it running on? What automation code ran? So this is where a lot of chaos comes in. So the question is, how does Shippable solve this problem? So what we do is we have a single RGM. And it looks something like this. There's code. It's not readable, but that's code sitting on GitHub. This is GitHub. And then we have our shippable CI, which is one of our products, and we use Docker Hub at this point of time. We are waiting for ECR to launch, and we'll be pushing it to ECR. And that's where all our images are stored. And then on top of it, we have this thing called Shippable Formations, which eventually pushes it into AWS Container Service. And that's kind of like our pipeline. This is built once, and we don't rebuild it again and again and again, and we keep reusing it for all the different applications. Now, once we have this RGM, the first thing we do is we ask our operations guys to give us the security hardened image on which all our applications are going to be built. So they maintain that, and we use our CI platform to test that and then push it as an image into the hub. Now, every single application that we build is built, and then the next thing they do is they provide a declarative YAML that tells me how my cluster needs to look like on Amazon. So it's very declarative. There's no coding. You're not writing Ruby code. You're not writing anything. It's just a YAML file. You could also do it in JSON. You could do a whole bunch of things out there. So that brings up my dev, test, and prod cluster on ECS. And they're all running on different VPCs, but there is exactly the same VPC rules across all the systems. And it's super easy to implement this, and we run that. Now, once that's done, dev goes and says, we're going to build 3 different applications. They all inherit from the same base image. They add source code into it, they run through CI, and we get what is known as a deployable image of those applications. And then once this is done, all we do is you basically create a declarative YAML about how to deploy these services, which is what ports are getting opened and stuff like that. You could use Docker Compose, you could use a whole bunch of stuff to actually declare this also. And then that actually brings up the dev environment. Now you run a whole bunch of automation tests, whatever you want, and whenever you're ready, you push that into test. And all you did is change one single field, and you got 2 copies of API running. You didn't actually go and say, I'm going to deploy a new infrastructure or anything like that, because the cluster takes care of all of it. And then, of course, you can take the same exact image and push it into production. So this is a pipeline where code propagates. The same thing goes through different versions running into environment to environment to environment. And that's the pipeline that we are kind of building. So this basically reduces the complexity to one single RGM. And the RGM just talks about how do I deploy a container into a cluster. And that's about it. And what are the configurations that I need. And everything else is declared in the code. So let's just see this in action. So this is my Docker Hub. I have a demo rep. Let's go to GitHub first. So in GitHub, I have these applications. There is a micro image on the base level. There is an API. There is a www application. There is a deploy configuration. And then we have a smoker, which is basically a smoke test that runs whenever an environment gets deployed. And all of this can be run end-to-end. I'll show you how to set this up. So if you go to the base image, it has nothing fancy. It has a Docker file. We install a whole bunch of things here, Python and Node and things like that that we actually use. It's a very, very simple Node.js-based application. So what I have done is on Shippable, let me log in into Shippable. So I'd already run the micro base image. I didn't want to waste time running all the images here. So this is already run. It's been pushed to Docker Hub. I already have an www also done. I'm going to just run the API from scratch to show you how actually we set it up. And if you go to Docker Hub and I go into www, you'll probably see a tag here. And that says master.1, which is equal to this particular tag. That was the first build that I ran for this particular application. So we have complete history of every single CI run tagged into Docker Hub so that we can deploy any version of this application at any given point of time. So we have like immutable images that done. If you're doing latest kind of deployments, it's going to bite you, so be careful, because someday you will have to do another production deployment and you will end up pulling all the vNext code if you're using latest as a tag. So you got to somehow create immutability in your tags. So that being said, what I'm going to do is I'm going to try to set up API real quick. So I'm going to jump in here. I'll show you how easy is it to set up CI. And what I'm going to do is I'm going to enable this. And what it did is it did a whole bunch of SSH keys and everything into GitHub, created automated deployment keys. I'm going to go set up a Docker build on this. I'm going to do it before I run the CI. I want to push this. I want to notify our system to say I am pushing an image. I'm going to give the Docker Hub micro.API. I want to change the push image. I want to keep the push image tag default. You could also make it static if you wanted, but I want the build numbers to be there. I'm going to leave that. And I know that in my Docker file, my code is getting uploaded into this folder, and that's my entry point. I'm going to save this. I'll also set up my hub integration, so I can use a Docker credential to talk to it, and I'll also set up a notification integration into Slack. So all the bills, everything is going to come into Slack at this point of time as it runs. So let me just start Slack so that it's going to this channel called sdemo. So we use Slack extensively, so let me just enter some stuff here so that we can separate this out. So what I'm going to do is, instead of going, I can basically commit something and run it, but I'm going to just run it manually for now, and this will fire off a build. So what this is going to do is it's going to now trigger a build, think as though that some user pushed something or some developer pushed something, it ran a build, it's going to go into our CI system, run through the entire workflow, and implement this. While this is running, let me just wait. Yep, it's going to start soon. Yeah, it started processing. You'll see a whole bunch of console logs. And this is basically trying to build the container, inject the source code into it, run a whole bunch of tests, and then if it all passes, it'll push it into Docker Hub so that you have an immutable version of this image sitting out there. Make sense? And so this is taking about 3 minutes. So in the meantime, I have set up my CI. I'll show you that if you go to Docker Hub right now and go to API, you'll probably not see any tags. So once this is done, you can see the tag gets pushed. And now what I'm going to do is I'm also going to set up a formation system. So what I'm going to do is I'm going to just buy a brand new formation. This is all in demo state right now. Let's call it AWS CD, container days. And then 8 gigs is fine. I'll just say demo at shippable.com. I'm going to just pick and start a 60-day free trial. And now I got my subscription set up to do the right-hand side of my part. Like the left-hand side is running right now, if you remember on the image. Now the first thing is it asks me, give me your AWS credentials because I want to push it to AWS. So I have set that up. And now what it's going to do is it's going to go and look for if you have any clusters that are already defined on AWS. We are pretty much searching every single region, so it's a little slow. It takes about 10, 15 seconds. And once that comes back, I don't have anything. So if you go into this and list clusters. I don't have anything across my entire system, so it's going to come back with nothing, and it asks me, do you want to create a new one from source? So what I'm going to do is I'm going to pick that. It asks me, where is your GitHub project where this source code for this or declaration for this cluster exists? And I'm going to pick up my deploy one. Oops. And I know it's in master, so I'm going to create it. So what it did now is it hooked up my deployment repository. So if operations changes anything, anytime into that repository, it automatically updates all my cluster definitions on AWS. So security patches, anything that they want to do, they just go add it to their YAML, saying run this apt-get or whatever distro you're using, and then it'll update on the system. So what I'm going to do is I'm going to manually provision this. So once I hit provisioning, oops, sorry, I made one mistake. Let me give myself access. It's using my account, so I always forget this. I'm going to go back and try again. OK, now it should work. So it finally triggered a deployment. And once you go into it, it is actually completely versioned. Your environments are versioned, so you can roll back and roll forward your environments without having to worry about, hey, I made a mistake, I want to go back to what it was just before. You don't need to worry anything. If you're trying to do anything else directly, you have to go back and roll back a whole bunch of stuff you don't want to do. Here, we maintain state of all of this. So it's going to run through all of this workflow, and eventually what's going to happen, it runs for about a minute. What you will see is a brand new VPC created for dev, along with 2 instances provisioned, load balancers provisioned, and AWS cluster along with policies and everything done for you. So it's an open source project. You can go look at what our definition is, and you can pretty much copy it, and you can run it yourself if you really want to do it. It didn't run for some reason. Let me just look at it. Should take, uh-oh. This sucks. So actually what happened is errored out. So if you see, it should show you some stuff. Yeah, actually it started creating clusters. And so what has happened is it basically created a cluster. Somewhere in the thing it failed, so I have to roll back the whole thing, but I won't do that during the demo. What I'm going to do is I'm going to show you how to set up the service here. So assume that this thing succeeded. And if I go to the status here, I can add a service. Let me start by micro.www. And then what it gives me is a whole bunch of information. I'll set up Slack notification. Now I want to create a new image. There is nothing here, so I'm going to do sdemo/micro-www. Oops. And I'm going to use Docker Hub integration. I'm going to create this image. Now it's going to try to sync all the tags so that I know what the tag is in my system. So what we are really doing is we are building a task definition dynamically for you. So this will generate a YAML, which will get pushed back to your repository that you can use to actually manage it afterwards. So the first time you create it, you don't need to hand author that entire task. So that's basically what it's doing. So it brought back my tag. I want to do this. I want to expose a port called, let's say, 3000. I want to make this external. Oops, the load balancer is not provisioned. So I'll just say 3000. I want to add this port. It got added. Now my image is there. So this is my service definition. You can add as many images as you want to create a service definition. And then I can add any kind of stuff, like I call it www_port. That's a variable that we require, 3000. And you can add these environment configs into it. And then once I do it, I can now talk about how many desired count I want of this service. All of this is generating that JSON file for you. And then eventually, you can hand code the JSON file and change it if you want, or you can change it on the UI, depending on how you want to think about it. So that's basically the deployment aspect of it. So what we can now do is you can create as many services as you want. So you can go back here. And let me just jump here and see whether the Docker run finished. Yeah, it finished. It pushed master.1. So now I can also create micro.api very similarly. And now you have load balancers, and you can route those in the configurations, and you're pretty much done. I mean, that's how simple it is to actually create services. And this is what we do on a regular basis. So if I want to jump quickly into how Shippable runs on top of it, I'll just show you how our service, this is our live service. And if I go into prod, so these are all the microservices that we have, and how many deploys have we done in the recent time. And these are all the things that are actually running the actual service. This is production. I can pretty much go into any of these deployments, and then I can go into console and get a live console from the actual service streaming back to me through AWS cluster, so that I don't need to SSH into 10 different pieces. So all of that is, this is actually production shippable running. So that's pretty much what I had for a demo perspective. If you think about DevOps as a whole thing, what we actually did was we completely decoupled operations and development. So operations owns images and infrastructure, and development owns applications. So there is no concept of each other stepping on each other saying, what ports do you want to open, how do you want to open it. It's all in the application config, and all the hardening, security, and all of that is in the infrastructure layer. So what we call simplified DevOps is really not trying to integrate these two things. It's almost like completely decoupling them so that each of them can do what they do best really, really well. And that's basically the direction that we are going. So question is, why did we use ECS as opposed to any other thing? There are tons of cluster services out there. So the main things were these. First thing is, we didn't need to deploy any software on top of anything to actually manage clusters anymore. I didn't have to have a master server running. I didn't need to maintain state. I didn't need to do anything. ECS took care of all of that. My infrastructure was still EC2, and I had my own VPC. So we didn't really have to change much at all to kind of make this transition. So the second thing is the cluster isolation between dev, test, prod was very easy with VPCs. I didn't really have to worry about any kind of permissions. It was running on a completely different network. It was different subnetting. It could be the same subnetting that runs in production that I could run in dev using VPCs. And that was the second big thing that we needed. And the thing about ELBs was a huge thing. Every time I needed to scale up or scale down, where we have our service watching mean time response and stuff like that, where I want to increase the number of copies of this service running. The load balancer configuration and all was automatic. I really didn't have to do any of the networking routing as long as I set it up the first time. And then, of course, I can do throttled upgrades. It does automatically the whole orchestration about which ones to bring down, which ones to upgrade, roll back, all of that stuff. And I could always go back to the prior version without having to change anything. And the most important thing was we have a ton of latency issues because we use images so much. Having ECR running on the same data center or in similar kind of availability zones is huge for us. So that allows us a ton of speed and performance that we get. I mean, we deploy 60 times to production a day. It's constantly deploying. And if you have like an extra 2 minutes, that's 2 hours of latency for us, and we just don't want that. And so that's basically how we think about it. And of course, one other problem we had was we needed security between which systems can pull what tags and all of that stuff. So the IAM-based security is a huge deal for us because pretty much everybody in our company who joins first day can start doing deployments. And so we need to make sure that the pipeline is secure enough across the board. I mean, that was the other big reason why we wanted it. So to kind of put this all together, right, before we started doing this kind of workflows with Docker and all of this, we've been using Docker for about 2 years now in production, right from point 2. But before Docker, I mean, we started the company back in 2013, February till about August of 2013, we were just doing traditional VMs. And that's how we were trying to build. And we needed about 3 environments. At that point, we had 14 microservices, so about 14 VMs per environment. They were pretty small ones. They were not really big ones. And that costed us about $4,000, $4,500 a month. And then if you kind of add deployments to it, because we didn't have container-based deployments, with full automation, it took 30 minutes to deploy one full stretch from end to end. And then if you kind of add that to, we were doing about 40 deploys a day. You kind of think about it, it adds to about $40,000 of lost opportunity cost of developers because they're waiting for this to finish because they're not going to change anything. Otherwise, you need to start doing all kinds of branching and all of that stuff because you have to wait for it. So they wait for the whole thing to finish. And so that's 30 minutes. And you're doing it 40 times, so 20 hours every day you're just waiting, doing nothing. And that's where a lot of these 53% thing comes, and there is a lot of chaos in this. Now, if you kind of look at it from with the whole simplified DevOps where we use containers, we decoupled everything, made it super streamlined. We dropped down into 9 VMs because we just needed 3 per cluster. And then, of course, there were bigger VMs because we needed to run a lot more load on it, but it increased the density on it. So the infrastructure cost dropped by about 50%. I mean, that was not that big of a deal. But the thing that changed was my deployments now started taking 60 seconds as opposed to taking 30 minutes. I could go from full 0 to fully baked deployment in dev in about 60 seconds. So developers did not wait anymore. So my last opportunity cost was only $1,400 a month as opposed to $40,000 before because of just waiting. And so that's a huge deal for us, and we can actually deploy faster. So to kind of think, summarizing it, 400 hours a month, waiting 20 hours a day, 20 working days, that's how we came up with that number, to 14 hours of waiting, and 44,000 to 3,900 bucks, 4,000 bucks approximately. So we were innovating at 28x faster and 11x cheaper. And that was basically the big thing about what we got out of simplifying DevOps, so we can actually innovate faster. So, and also along with it, we got multi-cloud and hybrid cloud very easily. Because Docker allows you to do all of this. Yes, you have to do data management behind and try to do some replication, but at least from my infrastructure perspective, I could move it around anywhere I wanted. And my infrastructure maintenance costs, like I had to manage 42 VMs, now I manage only 9 VMs. I mean, yes, EC2 makes it easy to spin those VMs, but I still need to patch it. I still need to make sure all of those things are running. So that operation cost is not going away. But now having that become 9 is much, much easier and faster for me to actually implement it. So to kind of thinking about it, and that's what we call as simplified DevOps. It still does me repeatability, quality, and all of those things, the comms thing that people talk about is still all maintained, but there's no waiting. And there's no writing a ton of DevOps code. I mean, that's basically what we're really going after. So to kind of put it all together, here is our product. There are two versions of it. There is a SaaS version, and then there is a dedicated version. And if you want to do SaaS, then you get a different workflow. If you want to do dedicated, it's the same exact pipeline, but it's a different workflow. You can do GitHub Enterprise and those kind of things which you're looking at. And this is the same pipeline that we use to deploy Shippable. So it's actually Shippable runs on Shippable, and it's kind of like how we test pretty much our entire application. So that's everything, putting it together, how we think about DevOps end-to-end for containers especially. So 2015, definitely year of containers. What I believe DevOps is just a philosophy of surviving by innovation. And that's all it is. It's nothing else. How you do it is left to you. And that's where some of the things is like, I don't believe we should be writing a ton of DevOps code. And of course, containers reduce a lot of inefficiencies that exist in this workflow. And it's mostly related to time and mostly related to size of what you're deploying, or deployable unit. And that's basically what changes the game and why it was not possible with VMs. A lot of times people ask me, you could do all of this with VMs. Yes, you can. But the issue is that every time in dev, a VM has to go through a snapshot, and that takes 20 minutes to get. And now I want to make one single package change. I need to do another snapshot on top of it. That's 20 minutes. Assume that you can do that somehow. You're much more stable. You don't change packages that often. Now you need to just talk about moving 2 gigs, 3 gigs images across networks and all of that stuff, which takes more time. So it's just this whole weight and time cost is what the main problem is. The concepts are not anything new. But containers make those weight and the time thing change significantly, exponentially, and that's what makes the difference. And of course, I truly believe, this is my personal opinion, that if you're writing DevOps code, your engineers are actually underutilized. They are not. You should be making everybody who can write code in your company actually writing customer features and not writing plumbing and automation code in order to make this actually work. Big companies can afford it, especially mid-size and companies that are trying to compete. It's a huge waste of resources. You want to kind of pick any platform. I don't care whether you use Shippable or not, pick any platform which does this for you as opposed to sitting down and writing Ruby code or any kind of code out there to make this happen. The question I really want to leave you guys with is, what parts of your DevOps can you simplify using things like ECR, ECS, along with things like Shippable? You can put anything else on each of these lists. The idea is about human capital is getting wasted. 53% of some of the most expensive resources that you can ever have in your team are doing things which mean nothing to your customers because they're all plumbing code. Of course, they get the benefit of it, but is it really worth doing it?